Okay, YouTube, this is my second video in my module on graphical analysis in which we're going to talk about even and odd functions, okay, and also their symmetry when you graph their graphs. But basically, let's start by the definition of even and odd, starting with even. We say that a function f is an even function if we substitute a negative x in for all the x values, we get the same thing as if we hadn't substituted in a negative x in the first place for all x values in the domain of f. So basically, we would say the right side of the equation of an even function doesn't change even if we replace that x with a negative x. So basically, our check is going to be, hey, let's plug in a negative x, and if you get the same thing back as what you started with when you didn't plug in a negative x, then you have an even function. Likewise, with odd functions, we still substitute a negative x. We say a function f is an odd function if when we substitute a negative x for all our x values, what we actually get is negative on the outside f of x for all x in the domain of this. So basically, this means that if every term on the right side of the equation of an odd function changes sign if x is replaced with negative x, then we have an odd function. In other words, we would say that this negative f of x is the exact opposite of the original f of x. And so what I want to do is I want to check these functions to see if they're even or odd, okay? And I'll show you how we do this and how we recognize whether it is even or odd. So let's look at these functions up here, starting with this x squared plus 6. So I have f of x equals x squared plus 6. So here's what we're going to do to check for even and odd. We're going to substitute a negative x. Substitute negative x for all x values. In other words, what we're going to do is we're going to find f of negative x. And just by substitution, this means that wherever I see an x, we're going to take it out. And I'm going to plug in a negative x. So simplifying this, what you're going to recognize a lot of the time is whenever you have an even exponent, and I kind of remember this, even functions have even exponents a lot of the time, not always. But we'd say when you square a negative, what happens to it? Well, it becomes positive again. And what I get here is x squared plus 6. And what I want you to recognize is we just found f of negative x, but that's the same thing as this f of x that we had in the first place. So essentially, this must be even. And also, we know it's even because this is the exactly the same as what we started with before we have it even substituted in a negative x. So this is an even function. So let's take a look at g of x here that says 7x to the third minus x to the first. And not to foreshadow too much here, but I notice this has odd exponents on everything. That's a good indicator that we might have an odd function. But we say, okay, so g of x is 7x to the third minus x to the first. What we're going to do is we're going to substitute in a negative x wherever we see an x. So again, substitution just means we're going to take out all these input values here. Blank to the third minus blank to the first. We're going to plug in a negative x. And so what I notice here is this. When I take negative x to the third, I get x cubed, but it's going to be negative. Negative times itself an odd number of times means that it's going to maintain its negativity. And so we say a negative times this positive 7 here makes this overall a negative 7x cubed. And I have a double negative here, which makes this a positive x. And what I want everybody to see here is this. This is g of negative x. But I also want you to notice that comparing this, we're going to write this down, this is the exact opposite of what we started with. And the exact opposite of what we started with, well, we started with a positive 7x cubed minus an x to the first. Now we have a negative 7x cubed plus an x to the first. And so what we're saying is this is essentially the opposite of the original function. And so what we're showing here is that when we plugged in a negative x, you can see that the definition over here says you get the exact opposite of the function you started with. So we can conclude that this must be an odd function. So this is an odd function, not only because it had odd exponents, is not the reason why, but it certainly helps you to remember that odd exponents, when you plug in a negative x, are going to start flipping signs of things. So this last one here, h of x, we're going to take a look at it. We say h of x is this x to the fifth plus 1. Now, before you go in, and start saying this is an odd exponent, what I want you to understand is we could technically say this is x to the 0 over here, and that has an even exponent on it. I am not going to include that. What I'm going to do is I'm going to do our normal check here, which means we're going to plug in a negative x, and we're going to say, okay, so what happens when I plug in a negative x for all x in the domain? In this case, because of the odd exponent, of course, a negative x times itself an odd amount of times, we're going to get negative x to the fifth plus 1. So I want you to compare this to the original h of x. Is it exactly the same? So h of x was positive x to the fifth plus 1. This is not exactly the same. So I can say that it is not even. And if it's exactly the opposite, which it's not, I notice that the x to the fifth changed its sign, but this positive 1 didn't change its sign, so it's not odd. So So we're going to say that this is neither even nor odd. So our check for even and oddness is to plug in a negative x and say, did it stay the same? Is it even? Or did it change completely and make it its opposite and become odd? So really quickly, what I want to do, hopefully quickly here, is explain what we notice when we look at graphs of even functions and odd functions. And I'll just come out and say it. Even functions always have y-axis symmetry. So when we want to talk about why do we have y-axis symmetry when we talk about even functions, it's because of this. Essentially, when you look at this graph of x squared minus 4, which is an even function, when we plug in a positive one, it looks like we get a height of -3, and that'd be easy to go plug in and check. But the same thing happens when we plug in a negative one. In other words, if this is our x value here, we're plugging in a negative x value, and what you notice is you get the same y value, you get the same f value. In other words, when we plugged in a negative x value over here, this is meant to be written as a -1, I'll write it that way. F of -1 here is actually equal to f of +1. And this happens with all of our x values. F of 2 is equal to f of -2. We get the same y value here for some given x value that is opposite of itself. So whenever you have this happening, for some x you plug in, you get f of x equaling to be f of -x. We get the same y value here, the exact same. Then you're always going to have y-axis symmetry with even functions, okay? So we'd say if let's put it this way. We'll say that if it's an even function, then xy implies that -x, the same y, is also on this graph. And so we'll get y-axis symmetry with even functions. And odd functions, we say have origin symmetry, which is an interesting type of symmetry. Remember, odd function means when we plug in a negative x value, so we have xy is on the graph, the original graph here, then we would say when we plugged in a negative x, we got the exact opposite of y. So we got negative y. And so what this would mean is, we could, by observation looking at this cubic graph here, when I plug in f of 2, we get +8 here. We get +8, which is our f of 2 value. When we plug in a -2, we get -8. In other words, we get the exact opposite of the regular f of 2, which was 8. We got the opposite of that. So what this means is, for every point on this graph, x, y, we're going to get -x, -y. I could say, hey, 1, 1 is on this graph. That means that if I plug in a -1, I'm going to get the exact opposite of what I did when I plugged in +1, which is -1 here, which is the opposite of +1. If this happens, then we get this thing called origin symmetry, which means if you were to trace a straight line back to the origin, basically these are the same distance away from the origin in either direction here. And 2, 8, if we were to connect this dot here and then go down to -2, -8, we would say that that is a congruent distance away from the origin. That's what I mean by origin symmetry. So all odd functions have origin symmetry. Cheers.